Hi there, this is Will Tonner from Lamp8 Audio, sound designer and audio engineer. And today we'll be looking at creating physical emitters within Unity along with Wwise integration. So we're going to create a dynamic object, but an actual physical object as opposed to the ambient one in the last video. And it's going to match a spotlight with similar dynamic properties. So the sound needs to not only reflect the position, which can be done through drag and drop functionality, lucky for us, within the Wwise toolbox, but it also needs to match the intrinsic color and intensity properties of the light object itself. So we will need to customize a C# script to get Unity to pass these custom values back to Wwise. And we'll be adopting a couple of scripts from other sources. So thanks in advance, and obviously credit to be given where due. We'll be taking a lot of the lessons that we learned in the previous video on ambient emitters and applying them today. So if you haven't taken a look at that, might be worth going back and having a quick check. But let's just jump straight in. So we're going to kick off the video as we always do in Wwise, and then we'll move over to Unity to have a look at some of the programming over there. But first things first, we have an actor mixer work unit set up, in this case called lighting demo, and we're going to build this unit on top of some of the other ones that we've looked at, so character and ambient already, and we can see some of the other ones that we'll look at in different videos here as well. Let's start with the light buzz sound effect. So essentially it's a very constant buzzing sound. If I load that up, we can have a quick listen to that. We've got a couple of loop points, so that just loops indefinitely around in the mix. So if I jump over onto the light tones group that we have here, essentially these are tonal buzzes that also loop indefinitely, so they work very much in the same frame as the light buzz sound effect, but the idea is that only one of these is playing at any one time, and it represents the color of the light at that given time as well. So they're a bit more synthesized. If we have a quick listen to these, so this is the blue tone. We can see our loop in and loop out points of how that track loops all together. Got a bit of reverb as well. Same with the green tone. And that'll carry on looping like that. And then we have our red tone. And this is the looping point. So the color can dynamically change within the game, and so the group of sound objects here designed specifically to represent that movement, not just between different vector positions from a 3D point of view, but as we cycle through the actual colors themselves, we want to change the sound there, not just the volume of it as it moves towards and away from the player. In conjunction with the light tones, we have these light kicks, and essentially a kick is triggered at the start of every light tone once the player input is received to change the color of the light. So if we look at the blue kick and we play that, it's very similar to the blue tone itself in the sort of timbre and the texture of it. And the reason being is that it is actually the same file. If I open the core file itself, you can see I've just taken a section of it and used that as the kicker. And if I go back to the blue tone, you can see we're actually using a larger part of the file. And we've done that for each of them. So if I go through to the green kick, and we look at that in the tone itself, you can see the large part of it. Same with red. The brilliant thing about this is that Wwise is intelligent enough to know that if you're just utilizing the same file, it doesn't need to. Say I made 50 different variations of these kicks and these tones using one file, it won't duplicate that 50 times. So your hard-earned sound budget from a storage point of view isn't going to be spent on the same sounds over and over again. Wwise is intelligent enough to recognize that it can just use the same source file over and over again. So that could be really useful. So there, essentially, the from a sound point of view, what we'll be using, we have our underlying buzz. We've got a synthesized tone that loops and a synthesized kick to represent each of the colors that will be cycling through. So we move from the audio section over onto the event section. Got another work unit here for lighting events, and our core event is the light buzz event. What light buzz does is it triggers the light buzz sound, and it also triggers all three of the tones at the same time. That might sound like it's going to play all of them at the same time, which might be a bit confusing, because the idea is that we play one at a time. Well, that's why we have our three separate events for each of the colors. So we have, if we use the light red example, because this is the one that's triggered in conjunction with light buzz at the start of the game demo, we'll see in a second. What it will do is when it starts, it'll also play the red kick sound. It will then set the volume levels of each tone respectively. So if we're playing the red sound, then we want the red one up in the mix at 0, so at flat. Then green is going to be set down to -12 dB, so it's practically inaudible, and the same for blue. So essentially we will always have all three sounds playing at once, which means that we can seamlessly move between them. We don't have to keep triggering the sounds, I don't have to keep starting from scratch, they'll just always be playing. We're just setting the volume of that so that we can hear certain ones over others. We're doing that using this set voice volume. So that's the light red trigger. When we hit the light green trigger, we do the same thing, except we trigger the green kick, and the blue and red are set to -12, and green is brought up to 0. And we do the exact same with blue and the blue kick. We've got a bit of a fade time as well of 0.5 seconds that we're doing in terms of how long it would take audibly to hear those changes in the game. And you can also put a curve in place. I've just got a standard linear one here, but if you want to go for a bit more of an aggressive curve, you've got those options too. So moving from the events and over onto the game syncs and into the RTPC side of what we're doing from a game parameter point of view, if we look at the lighting demo folder I've created here, we've got two specific RTPCs that we'll be using for this demo. The light intensity, which ranges from 0 to 7, and that reflects the parameter range of Unity's light intensity. So as with if you remember the current time RTPC from the last video, it doesn't matter if we actually exceed the range provided here, but it does make it easier to edit if we do keep within that. And in this case, we're not going outside the bounds of 0 to 7, so that's what we've set the range here. And based on the value provided, what we use this RTPC to do is to actually set the volume and introduce a high pass filter on the sound effects. So if I go back to audio, and I'll use one of our tones as an example of this. In fact, I think it's set at the highest level in RTPC. So light tone folder, RTPC. If we look down some of the RTPCs that we have set up, you can see here we've got the light intensity one. Let's play that blue tone and we can see what happens as we drop the intensity from the maximum through to the minimum. Drops massively in intensity throughout the mix, and we can do that for all of the ones that we have set up as well. There's the green tone. The same setup for the kickers as well. So if we play the blue kick at maximum intensity, and then if we can do it from the RTPC down here actually. If I go to the light intensity full, play at half, a little bit less space content, and minimum. So you can hear that it's had a distinctive effect on the volume through reducing some of those lower frequencies. The other RTPC that we had set up as well that you might have seen is the spot Doppler. Now, essentially, we're going to use this for when the light moves towards or away from the in-game listener object. So in that case, that's going to be the camera. The idea behind this is we create a realistic pitching effect as things approach us or move away from us. You'll know the siren effect. That's actually quite true to any tone or any consistent sound that's passing at speed, and you'll see the spotlight will move quite quickly within the game, so it does make sense to have a Doppler effect implemented. So within the light tones and light buzz items, there is another RTPC for spot Doppler, and it creates a very slight pitch fluctuation, and I do mean really slight. So actually, let's go back to the RTPC screen for tones. You can see we've got the spot Doppler. Now at first glance, it doesn't even look like it's doing anything. It's so minute, you just need to zoom in. So we keep zooming in, you'll start to say, oh, actually there is a bit of a curve going on. So our Doppler sits at default at 1, and we'll see how this value is passed back from Unity in a second. But ultimately, as it lowers and rises through this scale, it puts a very small amount of pitch fluctuation. Let's go through and play one of the blue tones, and we can get an example of that. I just need to bring the intensity back up to 7 as well. Zoom in so we can see the spot Doppler again. So very, very minor. The idea being that it just does it very quickly within the game like this. Them have the same sort of effect going through. You can use spot Doppler down here to mimic it as well. So very slight, but it gives it a bit of a dynamic effect, and that's what we're going for. We don't want to keep sounds static. If we can affect them in the game using parameters, let's do that, and let's make it interesting for the player as well. Final thing within Wwise, before we export everything out, is within share sets we have another share set I've got set up for an attenuation curve under lights. If I load that up, you can see we've got a bit of a roll-off effect going on. So let's bring that green tone back in again, and as we move further away from that, 120 game units to be specific, we can hear that roll off. There's a bit of a gradual curve that gets steeper as we get towards center point, and that's where we're standing directly in the light. When I stop that sound, you can hear a bit of a tail. Like I said, there is some reverb that we have going on consistently. If I jump back into the audio side of things and go into light tone, general settings, we've got a standard reverb here that's just set. It's not modulated in any way at all. Essentially, we just have that constantly on there to give a bit of a tail off effect, which isn't intrinsically there with the audio file itself. So that's why we add that in. So then, as with the rest of the work units that we've worked on before, if we jump over onto the soundback mode, then all we need to do is have it set for just lighting. I can go ahead, generate that sound bank, assuming it's all set up in the same position as it was last time, and we now have our sound banks exported in Unity. So let's jump over to Unity now, and we can finish off setting this demo up, and we can have a look at what it looks like in action. So now we're back over in Unity. We've got our demo project loaded up with everything laid out how it's been in some of the other videos. And what we've done essentially to get this spotlight up and running, very basic. It's already available as a pre-created game object. Essentially, we go game object, light, spotlight, and the end result is this spotlight that we have here with some of these intrinsic properties that can be changed. We have to make sure, and we have to do this for everything within Unity that we're sending back to Wwise, especially if it exists in the real world, so to speak, is we need to set a collider. So I've got a sphere collider component that I've created here as well, and I've set that to is trigger. If you remember from our ambience video, the collider object is what Wwise uses to update its 3D mapping of where the object is in relation to the listener. So if you don't have one, Wwise will post a console error for anything that exists without a collider. And the 3D mapping won't update, so you'll just get, in our case, you would just get this constant buzz and this constant tone, as if you're stood underneath the light the whole time. If it's positioned above you, or essentially it will just stay in a fixed location. So even if the light itself moves, Wwise won't know it's moved, and it will still sound like it's coming from the same place. So very important, but it does a good job of giving you an alert in the console if you haven't done that. Then we've got our bank script. We need to have this somewhere. So the best place to have it is within the object that calls it and uses it. So we're loading the lighting bank. And again, it's just a case of doing a drag and drop from the sound banks area down here into the object. And then we have our AK game object script. So one thing you might notice with the game object script here is that we have got a position offset set. The reason being is that if you can see here, we have the spotlight floating somewhat above the ground, like a few meters or so. Now, by default, in this sort of mesh here that you can't see, that's the collider that I was talking about. The spotlight itself is going to be where the sound emits from. Which is technically correct because it obviously would do in real life. However, the spotlight is invisible from a point source point of view. Where you can see the light is on the ground, so it makes sense really to have the sound emitting from the ground, from the area of effect, essentially. So the position offset is located here, where this box is. If I turn it off, minimize it like that, then you can see straight away where it was. Open it up again. So instead of it being here, if you look at where the spotlight is positioned and where it's arcing out to, it's actually arcing out to around this position here on the ground. Give you a bit of a different view from it, like that. So that's actually where the sound is going to come from. It is going to track this object, but Wwise is going to do calculations on the back end to go, okay, well, actually we need to move the sound source slightly and offset it. So that's essentially why we have that set up. So how do we control the light? How do we move it? How do we change the color and the intensity? Well, we've got the color and intensity set up by default. We're initializing it red and with an intensity of 7. But obviously we need to be able to dynamically change that. So we do that using a script we have here called spot control. And I'm going to load that up over here in our script editor. Scroll to the top. Now this script itself, I've adapted it from a Unity tutorial video that was specifically on a function called lerp, which is a way of seamlessly moving between coordinates or between values rather than just going from one to the other. It's about transitioning between them. It's a great video. I'll show you I'll send you put the link at the bottom of the video so you can have a quick look at that. I would definitely recommend it. It wasn't built with the idea in mind of there being audio attached. It was very much just that this is how you build it physically. So what I've done is taken that script and I'll point out whereabouts I've made amendments in it to update it to work with Wwise. So the first thing it does, essentially, when it wakes up, is the position, the intensity, and the color. They're set straight away, and they're associated to these variables that we have here. So that exists in the script anyway. What I've done is I've also included 2 post events. If you remember from how we have Wwise set up, the first thing we need to do is post light buzz. That starts that sort of atonal buzz in the background and also starts playing all the other sounds, technically at -12 when they're first starting. And then it plays light red, which keeps blue and green down at -12, which is where they are anyway. It plays the kicker for red, and it then ups the red volume to 0. And obviously just those 2 events are posted back to Wwise. Wwise does all that hard work, all that heavy lifting in the background. So if we move down to the update function, what we're doing every frame in addition to what the original script does, and as I say, I'd urge you to have a quick look at that and look at the video to see how it's all set up. But we're also, as well as changing position, changing intensity, and changing color, we also need to send back a value of light intensity through to Wwise. And we do that using the intrinsic light intensity. So we're not doing any sort of clever calculations. We're literally telling Unity, take the value from the spotlight for intensity and post that back to Wwise under the light intensity RCPC. Essentially that will update frame by frame, and Wwise will do whatever it needs to do in the back end to make sure that all the sounds are reflective of that. So obviously as the intensity goes up and down, we have that high pass filter that's reflective of that light intensity RCPC. The only other modification if we scroll down, we have these different functions. So we have a position changing function, an intensity changing function, and color changing. Now within color, I have had to add a couple of extra lines of code, and this is essentially to call back to our events, our light red, light green, and light blue events. So a light red one is always activated by default, and then we have the option of calling green or blue, and we do that literally by pressing V, B, or N on the keyboard for red, green, and blue. So essentially that's all of that does, and the script itself, apart from that, is entirely unchanged from how it how I interpreted it from the video that I'll link you to. So that's our core script. That powers pretty much all of the demo in terms of color, intensity, and the location of the light. The only other one we have, if you look down here as a script, is our spot Doppler script. We also have a spot UI script which I've written so that we can actually see the intensity as it changes. It just writes it on the screen. But our spot Doppler script, as I mentioned earlier, is the way that we introduce that Doppler effect that allows us to pitch up and down. Now, no credit to myself for this one. This was entirely borrowed from Kenneth Young, who wrote out the script all from scratch. It's a great little script. It does some incredibly useful calculations, essentially looking at the position of an object in this frame versus the frame it was before, and based on how far it's traveled, it kicks out a value under this Doppler pitch variable that essentially says, okay, it's traveled this far, so the rate that it's traveled is this, and it's a variation of the value 1, so that it will start at 1 as a flat rate for an object that isn't moving, and it dips, and I find the range tends to be between 0.8 to about 1.2 as it speeds up and slows down, but essentially don't have to worry about the calculation, and Kenneth's programmed that in himself. Essentially all we need to understand is that a value above 1 indicates that the object's moving towards the player, and in turn we have a slight increase in pitch, which is what we've already programmed in Wwise, and a value below 1 indicates vice versa, which again we've also programmed as well. So the value itself will increase or decrease respectively based on how far that object's traveled in each frame, as I mentioned. So we run the calculation every frame, and that result gives us an indication of the speed the object is traveling. So we can hear this in action, but the first thing is it's worth mentioning with these scripts and the Doppler effect scripts, you would need to create an individual script for every single object you wanted to apply this to. You'd also need a separate RTPC. Otherwise, you'll end up with a situation where if one object moves, all 10 other objects, if you had them programmed, if they were referencing that one script, the pitch of them would all change, which would sound very strange. You'd have a strange sort of pitch bend effect on everything in the game that has that script. So you do need to be separate, but it is just a case of copying and pasting this script and making a change. So the way that I took this script from its template, it had Doppler param as the sort of default template name. We just called that spot Doppler. You remember in the Wwise project, that's what we have it named for there. So that's actually it really from setting it up from a Wwise point of view. What we can go ahead and do is have a quick look at that in the profiler. We can see the game in action and give you a bit of an understanding of what the feedback looks like from how Wwise is interpreting audio and how it's kicking it back out to us. So here we are back again in the game world. We're exactly where our spotlight is. We've got it on quite a low intensity at the moment. You can see that within the profiler that they're all set to quite low, but the red is a bit more prominent. If I go ahead and up the intensity now, hear that increase, we go for it again, that's much brighter. And then if we start to cycle through some of the colours, so we have that red, I go ahead and put that into green. We hear that kicker, which we can see again in the profile is triggered. The green kick, the green tone volumes change as well as the blue and red. So what we'll do actually, we'll jump out of Profiler and jump into one of the builds themselves. The only thing about Profiler is it does drop the frame rate a little bit as it's reading and displaying some of the stats as Wwise processes them. So sometimes it's a bit easier to run as a build. Let's jump over into that. So we're back in the game again. Obviously we're using our ambient time to show that it's now nighttime. Spotlight's over there in the distance. If we change the intensity and change the colour from here, we should still be able to see that. Hear that in the distance, and that should be able to hear some panning of that as well. So that should be quite strongly in your left ear. And now in your right. And if we send that over towards us, you might be able to hear a slight bit of Doppler as it moves backwards and forwards. And if we change the colour as it comes towards us as well. And the intensity as well. So we can see Wwise is more than capable of doing all this sort of stuff on the fly, and it sounds great in terms of smooth, and you know there's no jagged areas, so to speak. It doesn't jump out at us. It sounds good, certainly from my point of view anyway. So I hope that was a bit of an introduction to objects, physical objects, and being able to associate sounds and properties to them to get to create quite an interesting profile for an object that moves around the game environment. Hopefully you found that useful. Please do share it if you found you think anyone else might find that useful at all. And I'll see you on our next video, which is about vehicles. Thanks very much.